Bismillahirrahmanirrahim. Assalamu alaikum. My name is Jamshaid and my role ID is 190994. So today I'm gonna show you how we make our line following robot using 6 sensors and other ultrasonic sensors and encoders and with help of SD card for logging data. So first of all I'm going to show you the basic design and basic hardware implementation of our robot. So this is the hardware implementation of our robot, where we use 6 sensors, one ultrasonic sensors, Arduino, and the chassis, and having 2 motors and LCD for displaying our current and voltage, increasing or decreasing by time, and the other thing is encoder, which we are using to calculate the distance which will appear on our LCD. So first of all we have to make the logic, and we have to build our code in order to follow the line. So for line following, first of all we have to write a code in Arduino IDE. So now first of all I am going to show you the basic code which we implemented on this hardware, and then perform our all the simulation at zero. So now as you can see, this is our main code, IDE code for our line following robot. So first of all we have to include LCD header files, liquid crystal, and then the new ping .h for ultrasonic. And first of all we have to sense for voltage sensor, and we have to define the voltage sensor inputs and A0, and with the help of float we are first initializing V out, which is our output voltage, and V required, which is our required voltage. First of all we have to reset it 0, and these are the 2 resistors having 30,000 ohm and 7500 ohm resistance value. So here we initialize the integer value is equal to 0. So this is here initialized for checking encoder, and after measuring encoders this will measure the distance with the help of our step. So when we are using encoder on our chassis, here are some circle having some step size, and which it calculated when the circle passes through the encoder. So with the help of these step sizes, our Arduino, our code will build up our step size, and then it will display our distance on our LED. So after initializing sensitivity and the ADC value to 0, and offset voltage to 2500, and the current voltage. So these are the 3 bool expressions, use L3, L2, L1, R2, R3, R2, R1. So after it we have to unsigned long PT0, and then constant long delay time. Here we have to delay of 500, and then so these are the pins of our liquid crystal display. So first of all we have to define all the pins. This is the RS34 enabler, and the data pin 4, data pin 5, data pin 6, data pin 7. So here we are going to use the 4 data pins. So we are just initializing, defining 4 data pins. No, we don't need to initialize the D1, D2 and D3. So here we initialize RS on 34 and enabler on 35, D4 on 45, and D5 on 43, D6 41, D7 39. So these are the pins of our Arduino, which we are going to connect it with these inputs of our LCD. So after initializing liquid crystal display, we have to initialize all the sensors input on our Arduino. So we are using 6 sensors: most right sensor, center right center, and center left center, and then left sensor, and then most left sensor. So the most right sensor is defined on 23 pin, right sensor defined on 25 pin, center right sensor defined on 27 pin, and center left sensor defined on 29, and left sensor defined on 31, and the most left sensor defined on 33. So after defining the pins of our IR sensor, we are going to define the pins of our motor driver. So first of all we have to define the right motor input 1 to the 9, and input 2 to the 8, and enabler A to the 10 and input 3 to pin 7 and input 4 to pin 6. So enabler B to our 5 pin. So this is the encoder input we have to define on our here Arduino on 22. So now after defining all the inputs on the pins of our Arduino of IR sensor, motor and encoder, we are going to define the pins for the inputs of our ultrasonic sensor. So this is the basic the initializing and defining of our all the pins on our Arduino. So our main function will run from here. So here you are seeing here ultrasonic sensor. So first of all we have to initialize the trigger pin on our 11 pin of our IDE and the echo pin on our 12 pin of IDE Arduino, and the maximum distance here we define is 200. So for defining maximum distance we have to use the formulatic way of our ultrasonic sensor, which we are initialized in at the end. So now we are going to move towards our sonar ultrasonic sensor trigger pin, echo pin and max distance. Here we define, and here we initialize the function unsigned integer distance. So here we call this. So now our function will start here, void setup. First of all we have to initialize the input and output pins with the help of our pin mod in IDE language. So the right sensor act as an input, center right sensor also is an input, most right left sensor, center left sensor and most left sensor act as an input. So our output will behave for our motor driver. So our motor driver, all the input act as our output. So the input 1, input 2, enabler A, input 3, input 4 and enabler B act as a output. So here this is the serial begin input, which is we are going to use to check whether our circuit is working or not here in our IDE software. So this is a voltage sensor input and encoder input act as an input, and after it we have to print on our LCD as a welcome. So this is the command is used just to print our welcome on our LCD. So here our function will run for our turn right, turn left, forward and backward. So for, as we know, first of all we have to move our robot to right. So in this case our left motor will start move and our right motor will stop. So first of all we have to analog right enabler A. So this is the PWM value is 190, which we are going to use our speed control, and enabler 1 and is start to high and enabler 2 remains low, and in left motor case both inputs are low. So in this case when our right motor will start, it will turn right. So in next case for turning our left, so in this case our just input 3 becomes high and all the inputs remaining become low, and we set the PWM value to 190 for our speed. So in this way our robot will turn left. So for straight movement we have to adjust in input 1 and input 3 as a high and input 2 and input 4 as a low, and set the PWM values on enabler, and with the help of analog right our robot will move in straight condition. So this is the as it is basic for backward when our just one input is remains at low. So here is the stop function when we have to stop. So in stop function just we have value to our 0. So in this case our robot will stop. So this is the main function of our voltage sensor. So first of all we have analog read. With the help of analog read we set the voltage sensor, and this value will store in our value value integer, and then this value multiplied by 5 divided by 1023, which is the maximum value. It will convert to its ADC conversion, it will convert to its digital conversion, which store in our V out integer, and this V out integer with the help of a voltage divider formula will calculate our V required, which will store in our LCD, and it will print on our LCD. So LCD segment with the help of this command LCD set cursor 101 mean row and 0 column. So LCD prints voltage, and then LCD print the V required, which we are calculated with the help of our voltage divider formula. So this is the just the for calculating and for showing voltage, changing voltage on our LCD display. So as it is for displaying current on our LCD liquid crystal display, we first analog read a current sensor, which current are we gonna accepting, and then with the help of ADC voltage, this value divided by 1024 maximum value and multiply by 5000, and then changes to digital, and then this digital value minus from offset value and divided by its total sensitivity, then gives the our current value which our robot is getting. So we have to now show this current value to our LCD. So with the help of this command LCD print, our value will print to our liquid crystal display on our second row, to mean second row. So now as it is, this is the use for our encoder for checking one. When encoder is 1, it will digital read the encoder value, and it will increase step size one by one. So here this is the function will represent when the encoder is 1, then it will read the value 1, and then as it is when step size and when whole spaces passes through the encoder, our step size will increase one by one. So now we are going to make the ultrasonic, and here we have initialized distance unsigned in integer, and this is the sonar ping function which we are calling, and then it will return distance. So now this is the loop for calling delay. As it is when we are writing in C language, and when we are writing here IDE language, we just call the ms delay function and our delay will call, but that delay will call some interruption in our robot when we are just like in C language, when we are writing some code and then call some delay, then this delay will perform in our whole robot. So this millis function is used for removing that interruption. So when our millis function will call, then our that delay time in call in just printing on our LCD, not in our whole robot. So such as we initialize some CT variable and then PT variable, and when delay time is 500, and when this condition will true, then our delay will call, otherwise will not. So this is the main millis function for calling our delay without any interruption in our robot. So this is the ultrasonic function for displaying or reading our sensors value, most left sensor, center left sensor, most right sensor, and center right sensor. This will read all the values from our sensors input, and then with the help of these inputs it will perform our function. So our robot will stop when the ultrasonic distance is less than 20. So we here set the range of our ultrasonic to 20, and then it will stop here. So here we apply the stop condition. It means when this condition will goes false, then our robot will stop. So for turning left, our center left sensor is high, and our our left sensor will high, and our most left sensor will high, and all the others will become low. Then in this case only our motor will turn left. So for turning right, for straight, our all the right sensors and our then our robot will move in straight condition. So for stopping condition, our right sensor, all the right and all the left sensor will remain off, then in this case our function will stop. So for priority when all the our sensors are high, then in this also case when our robot will stop, such as when we are moving on our line black line. So when here all the our sensors are on the black line, then our function will stop, and when our all the sensors on the white line, then in this also case our function will stop. So this is the main IDE code for our line following and for displaying all the encoders data, all the current values, all the voltage on our LCD, which is changing or not changing. So this is the main function of our line follower. And then all the equipments we are using, such as ultrasonic, infrared, encoder, for displaying all the values, and this also the function of our LCD for displaying all the current and voltage, ultrasonic values, and distance, total distance, with the help of encoder on our decode crystal display. So now we are going to move towards our Proteus simulation. So first of all we have to simulate it on our Proteus, and with the help of Proteus we are going to implement on our PCB, and with the help of printed circuit board we are going to implement on our hardware. So this is the Proteus simulation. First of all, here just we initialize all the pins on our Arduino to our sensors, LCD, ultrasonic, encoder, current sensor, motors, power supply, voltage sensor, and SD card. So here you can see here pins of Arduino IDE 23, 25, 27, 29, 31, 33, ground and VCC to our IR sensors, 6 IR sensors and 2 VCC and ground. And as it is, these pins are initialized to our LCDs and the ground VCC with the help of potentiometer for setting the brightness of our LCD. And these ultrasonic sensors are connected to our 11, 12 pin as we initialize in our IDE code. And these are the current sensor A1 current sensor and A02 our voltage sensor, and these pins are used for 46, 48, 50, 52 to our SD card, for performing our data logging operations and other operations. So now I'm going to show you the encoders. 22 pin of our Arduino is connected to our encoders. So these are the common power supplies, VCC and ground. Here all the VCC and ground of our whole system comes here. So now we have to implement this Proteus on our printed circuit board, and then with the help of this printed circuit board we are going to implement on our hardware. So this is the PCB design of our schematic which we are implemented first. So this schematic with the help of our copper board and the other process of PCB, we implement this PC design on our copper board, and then with the help of this copper board we are going to implement on our chassis, and then will perform that our function is working or not working. So now with the help of this I am going to show you the basic PCB design which we have implemented with the help of this PCB design. So this is our PCB design which we have implemented with the help of copper board, acid and the other procedures, and then after printed on it with the help of soldering, and here we use some jumpers. So these pins we are not going to use, so here we are not solder them, and these pins we are using here. So these is our soldering, as you can see here. So these is the basic printed PCB design. So here is the printed the name of our team Spartans. So here these pins are of Arduino pins. So the main motive of our and the main objective of our PCB design is to decrease our number of number of connecting wires and the most optimized form of our line following robot. So this is the arena where we are going to perform our line following robot. So this our robot will move accordingly on this arena with the help of our 6 sensors. So now I'm going to show you the basic report. So our proposal is to design our line following robot by using minimum 6 considerations including economic, technical, legal and planning. So by this project we are going we come to know that how can we manage our all the equipments in an easy way, how can we deal with our uh, elders, and how can we deal up with our customers, and how can we deal with others, and how can we understand others. This is the basic comparison of our few components because there are in market when we are going to use, there are also two types of components we are going to use. So every component has its own specific properties. So on the basis of these properties we are going to use our component. So these are the components we are going to use. So there are two types of sensors. So this IR sensors is less precise, and this is more precise in sensing the path, easily available in market but hard to find in the market this sensor. So don't cost much, but this has much cost than average sensor. So this can sensor can be operated digital only, and this sensor can be operated digitally and analog also. So many errors are possible in these error, but this is a most precise and accurate IR sensor. So the sensor we are going to use, because it is less precise, less costly, and we have to deal with our errors, we have to deal with our failures. So that's why we are going to use this sensor. So this is our motors, DC motors. So we are going to use simple DC motors. We are not going to use the Pololu motors because these are some tricky, and we just want our angular motion. So that's why we are going to use this DC motor. So some technical standards are procedure established requirement for duplicate technical work. So these are the cost effective. Our standards are our cost effective project financial management, design, constructor, reliability, current required speed, voltage required. So all the basic standards, all depending on all these basic standards, we arranged our equipment and we managed our equipment. So this is our team roles, and this is our work breakdown structure. First of all, we implement our code, and then simulation, Proteus, and then PCB making and ordering components, and then assembly of these components on our PCB and on our hardware, and then after it we test our final project. So this is our estimated budgets. We estimate this that we are going to implement. So this total amount is 7,105, which we equally divided in our group members. So this is a basic introduction of our robot which we are going to design. So we are going to design our robot having 6 sensors which will follow our line. With the help of these sensors, after the calibration of these sensors, it will follow line, and the current we applying and the voltage we applying and the motor driving giving our voltage and giving us current will display on our liquid crystal display. And with the help of Arduino we uploaded core, and we implement our robot on our SD card as well, and encoder to display the distance on our LCD. So here we attach 6 to 7 components on our line following robot. So this is a list of features. The robot is able to make turns in every direction, and the robot is able to make a complete turn when it reaches endpoint. So data logging is done using SD card, LCD to display all the data and voltage or current measurements as we have discussed before. So this is a project development process. We will discuss how we design and integrate our project. We will also highlight what software we are going to use to help us in our design phase. We will also discuss what components are used in hardware building, And now before we go into the design of the robot, we will discuss the importance of ultrasonic sensor and other sensors and encoders, SD cards. So these all the components discussion will help us in our FYP final year project also. So partnership takes a transport development. From development perspective, the mechatronic design process consists of three stages. Those are modeling and simulation, prototyping and deployment. So the phases that pass the project under these main categories are as follows. So recognition of need, conceptual design and specification, sensor and actual design, control system design, design optimization, Proteus software simulation, breadboard implementation, and at last PCB hardware implementation. So this is the basic flowchart of our whole system design system: conceptual design, specification, control system, Proteus implementation, circuit implementation on breadboard, and then on PCB after implementing and testing, and then after at last final testing after calibration. And when we detect any error, we have to eradicate it. So this is the basic block diagram of our system, where we are using one motor driver, two motors, SD card for data logging at Mega, and the six ear sensors for our line following robot. So this is a data sheet of our IR sensors, and this is our module pin definitions of our ultrasonic sensor. Here we use trigger, echo, ground, and these are the electrical parameters. So this is a Arduino Mega data sheet, pin configuration. As we can see here, when we are confusing and we look towards our the data sheet, so it will clear us. And then voltage sensor data sheet, which we are going to use in our project. And this is the data sheet of our motor driver, which will work on our H bridge. So this is the system consideration. So our main concern is to design a line follow robot using 6 sensors that can detect black line and move robot left and right, another one with the help of these sensors. So here we use 6 sensors: center left, center right, left sensor, right sensor, most left and most right. So these are the priority sensors. Here we give the priority to our most left and most right sensor. So this is the criteria for our component selection. Our components are Arduino at Mega voltage sensor, current sensor, encoder, 6 IR sensors, SD card, 16 cross 2 liquid crystal display, L298 motor driver, breadboard, copper board for implementing PCB design on our copper board, battery source, header pins, which we are going to connect all our components on our PCB, and with the help of header pins, first we are going to implement it. So motor driver and robot chassis and two motors, etching acid, etc. So this is the mechanical design process. So now we are going to talk about our mechanical design. So a robot is a machine which is completely automatic. It starts on its own and decides its own way of work and stop it on its own. So it is actually a replica of human being which has been designed to ease human burden. It is basically a robot which follows a particular path or trajectory and decides its own course of action which interacts with obstacle. So the path can be a black line on a white floor on a magnetic floor in field. This car or a robot is basically working on 6 sensors and compromises of ultrasonic sensor which is used that is there any obstacle or not. So voltage sensor is used to check the voltage which we are implementing, and the current sensor used to check the current which is connected in series with the load, and 16 cross 2 LCD interference to show the current and voltage of the circuit. Car has two DC motors that are attached to motor driver L298D. The 6 IR sensor are placed on the front of the car as two sensors are of the right straight line, and two for left and two for right sensor will decide whether to turn left or right. And the IR sensor has a transmitter and receiver. When we place the car on the arena, out of 4 sensors, 2 sensors were on the black line, and other 2 sensors has to be on the another 4 has to be on the white line. And if we placed all the sensors on the black line, it will give the correct output, and the car does not know whether it has to move right or left. So for the optimization of a design, for the optimization of our design, we connected the 6 sensor and ultrasonic sensor on the cardboard to make sure that we when card speed up, all the 6 sensor will not be damaged or move obstacle. It will affect the output. So when robot will detect the obstacle, it will move backward, and using 2 encoders that are placed on 2 tires will basically check the steps of the robot and tells the distance traveled by the robot. So by using these encoders, we will send data is further connected to the motor driver, which will decide whether to move right, left, or straight or stop. So this is the controlling for all the our hardware with the help of our 6 IR sensors. So on the basis of these sensors, our motors will run. So this is our component selection, the components we are going to use. So this is our L29 motor driver, and this is our pin configuration of our motor driver L298 pin, and this is our IR sensors. We are going to use infrared sensors, uh, and having two resistances on it, and having white or black priorities. And this is the basic schematic of our IR sensors. And the DC motors we are going to use energy to mechanical energy or imparts motion. It converts. Simply it is angular DC motor. This is our battery source cell, Leon 18650C, 200 ampere at 3.7 volt, giving 3.7 volt. So the Arduino at Mega we are going to use is this. These are the pin configurations of our Arduino at Mega 3 to 8P, but we are going to use at Mega 2560. So this is the current sensors we are going to use, and this is the voltage sensor we are going to use to read our voltage, which will display on our liquid crystal LCD. And this is our SD card module. Here we insert our SD card to save all the data in our SD card, and which will display our data logging. And this is the ground, VCC inputs, and MISO, MOSI, SCK, and CS input pins. And so the encoder is used to calculate the distance which is covering our robot. So here these are the core disk. Here some are the some are the holes which passes from the encoder, and then it will read our step size, and then display the distance on our liquid crystal display. So this is the liquid crystal display. Here we are going to use here 4 data pins, 4 5 6 7. A and K is used for light, to turn the brightness and to turn the light. The we are going to use right value, just we are going to use here RS and enabler. And others are used VCC and VDD with the potentiometer to set the brightness or contrast of our liquid crystal display with the help of potentiometer. So after regulating the system, we can set the contrast. This is the software design. We had This is the final our hardware simulation and implementation of our robot, as you can see here. And this is the truth table of when all the sensors are 0, then our output in this case is 0. When all our sensors are 1, then also our output is 0. When our right sensor is 1, then our motor will left move, because our left motor will start and our right motor will stop, and our robot will move to our right position. And if our center right is on, because this is a priority, so in this case our both the lefters will start on. So this is the basic operations on based on our IR sensors. Just like they have to move on and off, so just like this. So this is the block diagram of our Atmega 2560. Here we have IR sensors, ultrasonic sensor, voltage sensor, current sensors, encoder. So these are all the pins associated with all of our equipments. Now this is a basic code as we explained. First of all, we explained this code, ID code, for our line following robot, and for displaying voltage, current, and distance with the help of encoder on our LCD 7 segment. And then with the help of ultrasonic interfacing of ultrasonic, first we interface the ultrasonic, and then with the help of ultrasonic we detect whether there is a obstacle in range of 20 or not. So this is the basic code, ID code, which I explained before. So now we are going to show you the Proteus simulation, as I show you the Proteus simulation, and after it, I show you the PCB layout first, and then this is the 3D view of our backside when we have to implement on hardware. So this is the final testing of our robot. So this is our final robot, and then after implementing all of our logic and all of our code in our Arduino and all of our setting, this is the final hardware our robot. So now we have to apply, and we have to apply on our arena. So this is the chassis, and this is the some pictures of our car chassis on front, on right sensor, and these are the our sensor we're going to use. This is our motor, this is our Arduino at Mega. We used encoder, and working principle of this encoder. Here we has opaque area. When this opaque area passes through the encoder, then it will increase one step size, and with the help of this one step size, it will calculate distance, and which will display on our LCD 7 segment liquid crystal display. So this is our ultrasonic. We are going to use transmitter, and it will send rays to with the help of transmitter, and the with the help when detect with the object, it will send to the receiver, and with this procedure it will show there whether there is an obstacle or not. So this is the SD card we are going to use. This is a battery we are going to use. This is our final model picture of our hardware simulation of our line following robot with the help of all the 6 sensors: ultrasonic, encoder, a voltage sensor, current sensor, and Arduino at Mega 2560. So this is our arena. So we have to final test on our arena, as we tested and showed to our teachers that we have implemented all the simulations on arena. For arena implementation, we have to set the calibration of our IR sensor. So this is the method that how can we calibrate our IR sensors. So first of all, we have to mount the IR sensor about 1 to 2 inches, and then turn the potentiometer fully clockwise, and then set to the when our sensor is on the white, then it will turns off. When it is on the black, it will turns on. So with the help of this procedure step, and then we have to calibrate our sensors, and after calibrating, we have to implement it on our arena. So this is the every individual role what we have to do in the project as a group member. My duty is to simulate the logic on the software simulation process, and PCB designing, and other assembly project, and other building our logic code, and helping in interfacing of our sensors such as ultrasonic, etc. So the failures we have faced the so much is that we have faced the failure in our PCB making. When we are making PCB, then then due to the poor acid, we cannot be able to do the proper etching. So this is our project budget of some our alternate motor drivers, sensors, wheels, and other Jamshaid set, and other receiver, etc., and the other Arduino ID. So this is the conclusion. So that from this project we learned a lot about the Arduino at Mega 2560 and also 328P, and how it works in our daily life. We also learned about the sensors, encoders, ultrasonic sensor, SD card that plays an important role in the development of technology. So the designing of this project helped us a lot to rethink about the problems, the issues we faced in making of the robot. It will also help to the final year project and industries in future, when we are going to perform some operations, some functions in IDE as well. So the goal of our this project is to get students interested and excited about the fields of engineering, mechatronics, and software development as they design, construct, and program an autonomous robot. So the guidelines we are provided are simple to use, understand, and every being a powerful little device, microcontroller would be nothing without its hardware. So whenever we are not going to implement on hardware, we cannot come to know that our project is true and our logic is true or not in this case. So it is just like a brain that operates our body, whereas in this case body is made up of many components including motors, lights, sensors, encoders, voltage sensor, IR, ultrasonic, etc. So the motor provide locomotion, the sensor act as a triggers, and the light are used to implement as a warning devices, etc. So now I'm going to show you the final testing of our line following robot. This is our final testing of our line following robot, as you can see in this video.
ये इन दो पे ये मोटर चल रही है, ये टायर अब इस पे
Our left sensors will on, and our right motor will start moving. When all the sensors are on, then our motor will, both motor will stop. So when our right sensors on, then our left motor will start. Then our left sensors will on, then our right motor will start working. And when all the sensors are on, then our motor will stop. So as it is in second video which we made, just like this, where in this case our right motor will start on, and in this case our left motor will start on. When both all the sensors are on, then our motor will stop, and when all the sensors are off, then also in this case our both motors are off. So we are implementing it on our hardware. So this is the PCB design of our schematic which we have constructed in our Proteus simulation. So that's all from our side. Jazakallah khair.